Hi students, welcome to this section where we are going to discuss divisibility rules. We start with checking the divisibility rules of 2, 4 and 8. Now let me have a list of numbers over here, and as we keep learning the rules I'll keep checking them off. So we start with 2, 4 and 8. Now the way we will proceed is, first in this video we will learn the technique when you want to check the divisibility of 2, 4 and 8, and in the next video we will learn the reason behind the technique. Alright, let's get started. In the case of 2, if you want to know whether a number is divisible by 2 or not, you need to check only the last digit, and the last digit has to be divisible by 2 or it should be 0. So it can be either 0, 2, 4, 6 or 8. Say you have a number 1934. Now over here you can see that the last digit is 4, and therefore this number 1934 is divisible by 2. Alright. Now in the case of 4, you have to check the last two digits. The last two digits should be divisible by 4 or it has to be 0. Now for example, if you have the number 596312, you just need to check the last two digits, that is 1, 2, 12, right? Now 12 is divisible by 4. Therefore, the given number over here is divisible by 4. Alright, now let's move on to 8. In the case of 8, you need to check the last three digits. The last three digits should be divisible by 8. Then the whole number which is given will be divisible by 8. Let's take an example. Say you have 937808. Now if you want to check whether this number is divisible by 8 or not, you just need to check the last three digits. That's 808, because 808 is divisible by 8. Therefore this number given will be divisible by 8. Let's analyze the reason behind the divisibility rule for 2, 4 and 8 which we just learned. Let's start with 2. Alright, say I have a number 1938. I can write its expanded form as 1000 plus 9 into its place value, that's 100, plus 3 into 10 plus 1 into 8, or just 8, right? So this is the expanded form of 1938. Alright, now you can see that 1000, 100 and 10, these three place values are divisible by 8. So it does not matter what the digit over here is, right? Whether this is 1 into 1000, right? So it does not matter what digit occurs over here. Whatever the digit, whether it's 1 or 9 or 8 or 7, these numbers will be divisible by 2 because the place value itself is divisible by 2. Let me repeat, the place value, that is 1000, 110 is divisible by 2. So whatever digit occurs in these places, this will still be divisible by 2. Therefore, the divisibility test of 2 only concerns with the last digit of the number. Hence, if the last digit is divisible by 2, the given number will be divisible by 2. Alright, for example over here you can see that because 8 is divisible by 2, and we have seen already that these three numbers are divisible by 2, therefore when you add all these four numbers you get 1938, and 1938 is divisible by 2. Suppose instead of 8 it was 3, then you'll have seen that these three numbers over here are divisible by 2, but 3 is not divisible by 2. Therefore when you add all of these together you will get a number which is not perfectly divisible by 2. Alright, now let's extend this logic to 4. Let's write the expanded form of 1938. So this is the expanded form of 1938. We can observe that 1000 and 100 are divisible by 4. 10 is not divisible by 4 and 1 is not divisible by 4, right? So these two place values are not divisible by 4. That's why when you want to check the divisibility by 4, you need to check the last two digits. In this case, the last two digits is 38. Because 38 is not divisible by 4, hence 1938 is not divisible by 4. Alright. In a similar manner, when it comes to 8, you have to check the last three digits. Now you can observe that 1000 is divisible by 8, and this part over here, this is the last three digits. That's why when you want to check divisibility of 8, you have to check whether the last 3 digits are divisible by 8 or not, because anything above that, right, if it's a 5 digit or 7 digit or 10 digit number, any place value above 100, that is 1000 onwards, will be divisible by 8. So that does not concern us, and we just need to check the last 3 digits for divisibility by 8. Let's do this problem. The digits of all the 2-digit numbers of 8 are reversed. How many of the resulting numbers would be divisible by 4 but not by 8? Pause the video, try to do it on your own, and then let's do it together. Alright, I hope you have given it a try. Let's do it together. The question mentions that the number so obtained should be divisible by 4 but not by 8. Alright, let's start with writing all the 2-digit multiples of 8. 8 into 1 is 8. It's not 2 digits, so we don't write that. The other ones are 8 into 2 is 16. 8 into 3 is 24. So let's write all the 2-digit multiples of 8. 8 into 10 is 80. 8 into 11 is 88. 8 into 12 is 96. You'll see that 8 into 13 is a 3-digit number, so we don't write it over here. Alright, now it's mentioned that after you do this, the digits are reversed, right? So you can see that the number that you obtain after reversing the digits in the case of 16, 32, 56, 72 and 96 is an odd number, right? 16, if you reverse, you're getting 61, and an odd number will definitely not be divisible by 4, right? So therefore I can cancel out these numbers because these are odd. 32 becomes 23, you can see. 56 becomes 65, 72 becomes 27, and 96 becomes 69. So these are definitely not divisible by 4. Alright, now let's analyze the standing numbers. Over here we have 24. If I reverse it, it becomes 42, and 42 is not divisible by 4, right? 42 by 4 is the same as, say, if I do 42 by 4, I can take out 2 from the numerator and denominator. I'm left with 21 by 2, and that is not perfectly divisible. So 42 is not divisible by 4. Therefore, it does not satisfy this condition, divisible by 4 but not by 8. What about 40? If I reverse the digits, I get 4. 4 is divisible by 4 and not by 8. So it satisfies the condition. Similarly, 48 gives me 84. 84 is divisible by 4 but not divisible by 8. So these two satisfy the given condition. What about 64? If I reverse 64, I get 46, and 46 is not divisible by 4. So the given condition is not satisfied, right? Because 46 by 4 is the same as 23 by 2, and that is not perfectly divisible. Alright, now if I go on, 80 and 88, these are divisible by 8 when I reverse them, right? Over here I get 8 and over here I get 88, but in the question it's mentioned that it should not be divisible by 8. So therefore these two also do not satisfy the condition. Therefore I am just left with two numbers that satisfy the condition, that's 40 and 48. So the question asks us how many such numbers are there, and the answer is 2. In this video, let's learn about the divisibility rule for checking whether a number is divisible by 3 and 9. Alright, so far we have learned the divisibility rule for 2, 4 and 8. When it comes to the divisibility rule of 3, the sum of the digits should be divisible by 3. We will first learn the technique, and in the next video we'll learn the reason behind this technique. So let's apply this rule in an example. Say you have the number 9312 and you want to check whether this number is divisible by 3 or not. The rule says that the sum of the digits should be divisible by 3. So what is the digit sum of 9312? It's 9 plus 3 plus 1 plus 2. You'll get that as 15. You can see that 15 is divisible by 3. Therefore, 9312 is also divisible by 3. Alright, now let's move on to the rule for 9. For 9, the sum of the digits should be divisible by 9. That's the divisibility rule for 9. Let's take an example. Say you want to check whether 73431, whether this number is divisible by 9 or not. Alright, let's find the digit sum. The digit sum is 7 plus 3 plus 4 plus 3 plus 1. When you do that, you'll get the sum as 18. You can see that 18 is divisible by 9. Therefore, 73431 is also divisible by 9. In this video, let's try to understand the logic behind the technique which we learned to check the divisibility of 3 and 9. Alright, let me take a number 9312 and write its expanded form. Alright, so 9312 is equal to 9 into 1000 plus 3 into 100 plus 1 into 10 plus 2. Alright, if you add this, you will get 9312. Therefore, this is the expanded form. Now, I can write 1000 as 999 plus 1, right? And I can write 100 as 99 plus 1. And I can write 10 as 9 plus 1. Let me implement that. So this becomes 9 into 999 plus 1 plus 3 into 99 plus 1 plus 1 into 9 plus 1 plus 2, right? Alright, so we have just transformed these numbers. We have manipulated them a bit. Now, using the distributivity of multiplication over addition, I can take these out, right? So let me take that out and I write it together. So that becomes 9 into 999 plus 3 into 99 plus 1 into 9. So I've taken that out and I'm left with 9 into 1, 3 into 1, 1 into 1 and 2, right? So let me write that over here. So that's 9 into 1 plus 3 into 1 plus 1 into 1 plus 2. Alright, so we have transformed this expression into this format over here. Now, you can observe that this part over here is divisible by 3 and 9, right? Over here you have 9, over here you have 999. So this part is divisible by 3 and 9. Over here you have 99, 99 is divisible by 3 and 9. Over here you have 9, 9 is also divisible by 3 and 9. So this section over here is divisible by 3 and 9. So when it comes to checking whether the given number is divisible by 9 or 3, only this part plays a role. And you can see that this over here is nothing but the sum of the digits 9, 3, 1 and 2. That's the digits of this number. So this is nothing but the sum of the digits. Now you can see if the sum of the digits is divisible by 3, the number given is divisible by 3. Similarly, if the sum of the digits is divisible by 9, the given number will be divisible by 9. Let's try to do this problem. You're given a number 798A523 and it's mentioned that this number is divisible by 3. The question asks us to find all the values A can take. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Now, over here, it's given that this number is divisible by 3. And we know that to check whether a number is divisible by 3 or not, we need to take the digit sum. Alright, let's find the digit sum. The digit sum of the given number is 7 plus 9 plus 8 plus A plus 5 plus 2 plus 3. If you add the numbers, you'll get 34 plus A. Now, it's mentioned that this number is divisible by 3. Therefore, 34 plus A, which we get over here, should be divisible by 3. Alright, now what are all the possible digits? It's 0, 1, 2, 3 up to 9, right? Let's check which all is possible. If you take 0, 34 plus 0 is 34 and 34 is not divisible by 3. Therefore, 0 is not a possible answer. Now, what about 1? 34 plus 1 is 35 and 35 is not divisible by 3. How do you check that? You can just add, in the case of 35, you can just add 3 and 5, that comes to 8, right? 8 is not divisible by 3. Therefore, 35 is not divisible by 3 and hence 1 is also not a answer for us. Now, if we take 2, 34 plus 2 is 36. If I add 3 and 6, I get 9. 9 is divisible by 3. Therefore, 36 is divisible by 3. Therefore, 2 is one of the possible answers. Now, let's do the same with 3 and 4. You will see that 34 plus 3 is 37, which is not divisible by 3. 34 plus 4 is 38, which is not divisible by 3. If you take 5, you get 34 plus 5 is 39. 39 is divisible by 3. You can also think of it like 3 plus 9 is 12. 12 is divisible by 3. Therefore, 39 is divisible by 3. And hence 5 is one of the possible answers. Let's move on. If you try 6, 34 plus 6 is 40. 40 is not divisible by 3, right? Similarly, 34 plus 7 is 41. 41 is not divisible by 3. 34 plus 8 is 42. 42 is divisible by 3, and 34 plus 9 is 43. 43 is not divisible by 3. Therefore, the possible values that A can take are 2, 5 and 8. In this video, let's try to learn the divisibility rules for 5 and 10. So far, we have learned the divisibility rule for 2, 4 and 8. We have also learned the rule for 3 and 9. Alright, in the case of 5, the last digit of the given number should be 0 or 5. Let's take an example. Say if you have 245 or 3940. These two numbers are divisible by 5 because the last digit over here is 5 and the last digit over here is 0. Now, when it comes to checking the divisibility of 10, the last digit has to be 0. For example, 300 or say 1940. These two numbers have 0 in the units place. Therefore, these two numbers are divisible by 10. In this video, let's try to learn the logic behind the technique that we learned for checking the divisibility of 5 and 10. Alright, now let's think of it in two angles. We know that all the multiples of 5 end in either 5 or 0, right? 5 into 1 is 5, 5 into 2 is 10, right? 5 into 3 is 15, 5 into 4 is 20. So in a similar manner, all the multiples of 5 either end in 5 or 0, right? Similarly, all the multiples of 10 end in 0. 10 into 1 is 10, 10 into 2 is 20, 10 into 3 is 30. You can see that all the multiples of 10 end in 0. Therefore, the reverse is also applicable. If you have a number and if it ends in 0, you can see that it is a multiple of 10, therefore it is divisible by 10. Similarly, if you have a number and if it's ending in 5 or 0, we can say that it's a multiple of 5. Therefore, the reverse is true. That number can be perfectly divided by 5. Alright, that's one way of thinking about it. What's the other way? Say I have a number 495. Let me write its expanded form. That's 4 into 100 plus 9 into 10 plus 5, right? Now, I can see that 100 and 10, these two place values are divisible by 5 and 10, right? So it does not matter what the digit over here and here is. Whatever the digit, whether it is 7, 4 or 5 or 9, it does not matter. These two parts will be divisible by 5 and 10. So, but it's not the case with 1, right? Therefore, the divisibility of 5 and 10 depends only on the last digit. And we have seen in the case of 5, the last digit has to be 5 or 0, because in that case, you will get a remainder of 0 when you divide the number with 5, right? Because 5 by 5 gives you a remainder of 0 and 0 by 5 also gives you a remainder of 0, though the quotient is also 0 in that case. Similarly, in the case of 10, the last digit has to be 0 for the whole number to be perfectly divisible by 10. In this video, we'll learn a very important technique to check whether a given number is divisible by a composite number. Alright, let's quickly think of what we have learned so far. We have learned the divisibility rules for 2, 4 and 8. We have also learned the rules for 3 and 9, and we have learned the rules for 5 and 10. Alright, now over here we have 6. 6 is a composite number, right? It's not a prime number, therefore it is a composite number. Alright, now if I want to check whether a given number is divisible by a composite number, I need to express the composite number as a product of co-prime numbers. What do I mean with co-prime numbers? These are numbers which have no other common factor other than 1. Alright, so let me express 6 as 6 is equal to 2 into 3, and with this example we'll understand this in a better manner. So I am writing 6 as 2 into 3. Now if a number is divisible by 2 and 3, it's divisible by 6. For example, let's take the number 498. We can see that the unit digit is 8, therefore it's divisible by 2, right? We have learned the divisibility rule of 2. And what's the digit sum over here? 4 plus 9 is 13. 13 plus 8 is 21. 21 is divisible by 3. Therefore, 498 is divisible by 3, right? Therefore, because 498 is divisible by 2 and 498 is divisible by 3, therefore we can see that 498 is divisible by 6. Now remember, over here 2 and 3 have no common factor other than 1. Let me make some space over here. The important thing that you need to keep in mind when applying this principle is, over here 2 and 3 have no common factor other than 1, and this type of numbers, that is, you have two numbers which have no common factor other than 1, these are called co-prime numbers. So don't need to be necessarily prime. For example, 25 and 64, we know 25 is not a prime number, it's 5 square, and 64 is 8 square, that's also not a prime number. But 25 and 64 have no common factor, or the HCF of 25 and 64 is equal to 1 because there's no common factor. So 25 and 64 are an example of co-prime numbers. Alright, now let's move on. Let's take one more example so that you understand this rule very well. Say you want to check whether a given number is divisible by 12. Alright, now I can write 12 as 6 into 2, or I can write 12 as 4 into 3. Now you need to know that checking whether the given number is divisible by 6 and whether the given number is divisible by 2 is not sufficient to establish that the given number is divisible by 12. Let's take an example. Say you have the number 6. 6 is divisible by 6. Yes. 6 is divisible by 2. Yes. But 6 is not divisible by 12. Right? Now this has not worked because 2 and 6 are not co-prime. There is a common factor of 2, right? So these are not co-prime, so this is not sufficient to establish whether the given number is divisible by 12. Alright, now when it comes to 4 and 3, it is sufficient because 4 and 3 are co-prime numbers. So what do I mean when I say it's sufficient? Let me make some space over here. To check the divisibility by 12, the given number has to be divisible by 4 and it has to be divisible by 3. So if that is satisfied, the given number is divisible by 12. Let's, for example, construct a number that will be divisible by 12. I know for divisibility by 4, the last two digits have to be divisible by 4. So let me keep it as 44. I know that 44 is divisible by 4, right? Okay. Now, if I want a number to be divisible by 3, the sum of the digits has to be divisible by 3. Over here, I have 4 plus 4, that's 8. Now, if I add 1 to it, 4 plus 4 plus 1, that's 9, right? So, this number over here is divisible by 3 and this number is divisible by 4. Therefore, this number will be divisible by 12, and you can see 144 is nothing but 12 into 12, and hence 144 is divisible by 12. Let's do this question. How many 3-digit numbers are divisible by 5 or 9? Pause the video, give it a try, and then let's try to do it together. Alright, we are back. Let this represent the numbers that are divisible by 5 and 3-digit numbers. Alright, so this set of numbers will be the numbers from 100 till 995. Now how do you get that? You can do that in this method. Take the smallest 3-digit number and the smallest 4-digit number, right? Because it's mentioned that you want 3-digit numbers. Now the smallest 3-digit number is 100. The smallest 4-digit number is 1000. You can see that 100 is divisible by 5 because 100 by 5 gives you remainder 0. So you start with 100 itself, and 1000 divided by 5 also gives you a remainder 0. That's because 1000 is a multiple of 5, and we know from the unit digit also we can identify that this is a multiple of 5. So we just move 5 units back to 995. So this set of numbers is the numbers from 100. The next one would be 105. The next one would be 110 up to 995. And we can observe that 100 is 5 into 20 and 995 is 5 into 199. Alright, now let me make some space over here. Let's do the same thing for numbers that are divisible by 9. Say this represents all the numbers that are divisible by 9 and are 3-digit numbers. Alright, now what are the numbers over here in this set? Again, let's take the smallest 3-digit number, which is 100. and the smallest 4-digit number, which is 1000. Now if I do 100 divided by 9, I get a remainder of 1, right? My quotient will be 11 because 9 into 11 is 99 and my remainder is 1, right? Now you can also think it in terms of digit sum. We have learned that the sum of the digits will give us the remainder when you divide by 9. 1 plus 0 is 1. So 100 by 9 gives you a remainder of 1. All right. Now that indicates that 100 minus 1, that is 99, is a multiple of 9. Now 99 is not a 3-digit number, so to get the next higher multiple of 9, you add 9 to it, and that's 108 over here. Similarly, 1000 divided by 9 also will give you a remainder of 1, so you move back by 1, so 999 is also a multiple of 9. So this set of numbers are the numbers from 108 up to 999. Now you can observe that 108 is 9 into 12, and similarly 999 is 111 into 9. Alright, now this section over here, the intersection area over here, is divisible by 5 and 9, right? Now you can see that 5 and 9 are co-primes, right? Because there is no common factor among 5 and 9. Therefore I can say that this area is numbers that are divisible by 45. 5 into 9 is 45. We have seen the reverse of it. When we wanted to check divisibility of 6, we checked whether the number is divisible by 2 and 3, and remember 2 and 3 were co-primes. Similarly for 12, we check the divisibility of 3 and 4, and 3 and 4 are co-primes. So over here, this set of numbers is divisible by 5 and 9. 5 and 9 are co-primes, so I can say that this set of numbers that will occur over here are divisible by 5 into 9 or 45. So what are the multiples of 45? 45 into 1 is 45, 45 into 2 is 90, so that's close to 100, which is a 3-digit number. So 45 into 3 is 135, and I can see that this set of numbers goes on from 135 till 990, right? Now why 990? You can think of it in this manner. Let me take 999 and divide it with 45, so it goes 22 times, you can see, and you get a remainder of 9. So you can just subtract that 9 from 999. So 999 minus 9 gives you 990. You could have done the same with 1000 also. You would have got a remainder of 10, and 1000 minus 10 also will give you 999 990. All right, so this is the set of numbers over here. Now you can observe that 135 is 45 into 3 and 990 is 45 into 2. All right, having established this, let's try to solve the problem and get to the answer. I'm keeping this aside. Now we need to find the numbers that are divisible by 5 or 9 among these numbers, right? So pictorially you can imagine that the numbers divisible by 5 or 9 is this area, right? This yellow area over here. So we need to find this total area over here. Now you can see that that is equal to the numbers divisible by 5 plus the numbers divisible by 9 minus the numbers divisible by 45, right? 45 is divisible by 5 and 9. Now why do we subtract that? Because when we add this and this, we are adding this section 2 times, right? Because it's part of the numbers divisible by 5 and it's part of the numbers divisible by 9. So to avoid double counting those numbers, we have to subtract them 1 time. All right, now when it comes to the numbers divisible by 5, that's 5 into 20 till 5 into 199. How many numbers are there involved over here? You can find out that by 199 minus 20 plus 1. How do you derive this? Say you have the numbers 1, 2 up to 10. How many numbers are involved? That's 10 minus 1 plus 1, right? 10 is the last number, 1 is the first number, and you have to add 1 to it. So 1 to 10, we know it's 10 numbers. 10 minus 1 is 9, 9 plus 1 is 10. Similarly over here you have the numbers from 20 till 199. So if you want to add the numbers from 20, 21, 22 etc till 199, you have to do 199 minus 20, right, plus 1. That gives you the answer as 180 over here. All right, Let me make some space over here. When it comes to numbers divisible by 9, we have the numbers from 108 till 999. So that's the numbers from, you need to count the numbers from 12 till 111. That's equal to 111 minus 12 plus 1, and you can see that that is equal to 100, right? And similarly, the numbers which are divisible by 45 are the numbers from 135 till 990. That's 22 minus 3 plus 1, which gives you 20. And therefore your answer is 180 plus 100 minus 20. That's 280 minus 20, which is equal to 260. Let's do this question. How many integers from 1 to 200 are divisible by 3 but not divisible by 7? Pause the video, give it a try, and then let's do it together. Alright, I hope you have given it a try. Let's do it together. Let this represent the numbers that are divisible by 3, and let this represent the numbers that are divisible by 7. And this section over here is the numbers that are divisible by 3 and 7. That is, they are divisible by 21. Why is that? Because 3 and 7 are co-prime. So if a number is divisible by 3 and 7, it's divisible by 21. Alright, now we are taking the integers from 1 to 200, right? So to find out how many numbers are divisible by 3, when you take the numbers from 1 to 200, all you have to do is 200 divided by 3, that's 66, right? It's 66 point something. So you have 66 numbers up to 200 which are divisible by 3, and you can note that 66 into 3 is equal to 198, and that's very close to 200, right? Similarly, if you want to find the numbers up to 200 that are divisible by 21, all you have to do is you have to find out 200 divided by 21, that's equal to 9. Alright, so let's see what the question asks us. Numbers that are divisible by 3 but not by 7. So all we need to find is this area over here, right? So from 66, which is this area, we need to subtract this part, right? This part has to be subtracted so that we get this section over here. That is equal to 66 minus 9, which is equal to 57, right? Therefore our answer is option B, which is equal to 57. You can also note over here that instead of finding it like this, you can also think of it like this. The numbers that are multiples of 3 are 3 into 1, 3 into 2, etc. up to 3 into 66. That's 1, 2 up to 66. That's again 66 numbers over here. Similarly, the numbers that are divisible by 21 are the numbers 21 into 1, 21 into 2 up to 21 into 9, and that's 9 numbers over here, right? 1, 2 up to 9, and again you have 66 minus 9, which is equal to 57. Let's do this question. 798A524 is divisible by 6. Find A. Pause the video, give it a try, and then let's do it together. Alright, in the question it's mentioned that the given number is divisible by 6, and we know 6 is a composite number. Therefore, let's write it as the product of two numbers which are co-prime. So I can write 6 as 2 into 3. Now the given number 798A524 is divisible by 2, right? Because the unit digit over here is 4. Therefore, it's divisible by 2, right? Because this digit is divisible by 2. Alright, so we only have to check for divisibility of 3. For divisibility of 3, we know that the rule is that the digit sum has to be divisible by 3. Let's find the digit sum of the given number. That's 7 plus 9 plus 8 plus A plus 5 plus 2 plus 4. If you do this addition, you will get it as 35 plus A. Now 35 plus A has to be a multiple of 3. Therefore, the possible values of A are 1, 4 and 7. 35 plus 1 is 36. This is divisible by 3. 35 plus 4 is 39, and 35 plus 7 is 42, and these are divisible by 3. Therefore, if A is 1, 4 or 7, the given number is divisible by 6. In this video, let's learn the divisibility rule for 11. So far we have covered all these rules for checking the divisibility. Now let's learn the rule for 11. Say you have a number 61809 and you want to check whether this number is divisible by 11 or not. The rule to be applied in this case is give a positive sign to the rightmost digit. The number next to it will take a negative sign. The number next to it will take a positive sign, and do that throughout the number. Remember, you need to start from the right to the left. So let's do that. Alright, so 9 has a positive sign, 0 has a negative sign, 8 has a positive sign, 1 has a negative sign, 6 has a positive sign. Now all you need to do is you need to add this value applying the signs. So that's plus 6 minus 1 plus 8 minus 0 plus 9. When you do this, you get, in this case you can see 6 minus 1 is 5, 5 plus 8 is 13, and 13 plus 9 is 22. Now the number you get in this manner should be either 0 or a multiple of 11 for the given number to be divisible by 11. Now in this case you can see that 22 is divisible by 11, therefore 61809 is divisible by 11. We'll see in the next video why this works. Let's learn the reason behind the technique which we learned for checking the divisibility by 11. Let's take the number 6380 and write its expanded form. So I have 6 into 1000 plus 3 into 100 plus 8 into 10 plus 0. Alright, now I can write 1000 as 1001 minus 1, right? And I can write 100 as 99 plus 1. I can write 10 as 11 minus 1. Let me implement that. So this becomes 6 into 1000 minus 1 plus 3 into 99 plus 1 plus 8 into 11 minus 1 plus 0. Alright, now let me take this part out and write it together. So that's 6 into 1001 plus 3 into 99 plus 8 into 11, and I'm left with this part, 6 into minus 1, 3 into 1 and 8 into minus 1. In this case over here I have 0. If there was some number over here, that also would be clubbed with this section. So I have over here minus 6 plus 3 minus 8 plus 0. Alright, now you can observe that this section over here is divisible by 11. Now you can see you have 11 over here, you have 99 over here, and you can note that 1001 is 990 plus 11. 990 is 11 into 90, right? So this over here is 11 into 91. If you do 11 into 91, you will get 1001. Therefore 1001 over here is also divisible by 11. Therefore we can see that this section over here is divisible by 11. Now when it comes to checking whether the given number is divisible by 11 or not, only this part matters, and you can see that that's the same as what we have done. Give plus to 0, minus to 8, plus to 3 and minus to 6. So that's minus 6 plus 3 minus 8 plus 0. Remember, the plus is on the right and you start from the right to left, alternating between plus and negative. So this amounts to minus 6 plus 3 minus 8 plus 0, and when you do this you get your answer as minus 11. Now because minus 11 is divisible by 11, right? Therefore 6380 is also divisible by 11. Don't worry that it's a negative over here. The value that you get over here should just be divisible by 11, whether it's minus 11, minus 22 or 11 or 22 or 33 or 0. In all of these cases the given number will be divisible by 11. Let's see one more way of thinking about this. Say you consider 1 by 11 and take the remainder. So we know 1 by 11 gives a remainder of 1 itself because it goes 0 times, right? Now let's take 10 by 11. 10 by 11 gives you a remainder of 10, or that's equal to minus 1, because over here you can see 10 is equal to 0 into 11 plus 10. That's why the remainder is 10. And in this case you can write it as 10 is equal to 1 into 11 minus 1. That's why the remainder is minus 1. So a remainder of 10 or a remainder of minus 1 means the same thing. when the divisor is 11. So you can see that 10 plus 1, the absolute value over here, 10 plus 1 is equal to 11. So for example, if you had 9 over here, 9 and minus 2, remainder of 9 and minus 2 is the same, or the remainder of minus 9 and 2 also is the same. The meaning is the same in both the cases. All right, let me make some space over here. Now let's take our number, say it's 6380. Now you can see that in the ones place, this is the ones place, and we have done 1 by 11. The remainder is 1, that's plus 1. That's why we have a plus over here. Now in the case of 10, that's the tens place, 10 by 11, we got a remainder of minus 1, and that's why we put a minus over here, right? Similarly, in the case of the hundreds place, this is the hundreds place. So 100 by 11 remainder is 1, because 100 can be written as 99 plus 1. So we put a plus over here because it's plus 1, right? Similarly, in the case of the thousands place, you will have negative. So that's another way of looking at the reason as to why this method works. Let's try to do this question. If 8A5146B is divisible by 88, then what is the value of A into B? Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. The given number is 8A5146B. Alright, now, and we have seen that it's divisible by 88. That's what is given. Now 88 can be written as 8 into 11, and we observe that 8 and 11 are co-primes. So if the number is divisible by 88, it means that this number is divisible by 8 and this number is divisible by 11. Alright, we have learned that in the case of composite numbers, this is the rule applied to check for divisibility. Alright, now let's start with 8. If this number has to be divisible by 8, then the last 3 digits has to be divisible by 8. Now 46B should be divisible by 8. We can see that 464 divided by 8 gives a remainder of 0. Therefore, the value of B has to be 4. You can just, to find this, you can do it in this manner. 460 divided by 8. If you do 460 divided by 8, you can see it goes 5 times. You have 40, you get 6, and that's 60 over here. You can see it goes 7 times, that's 56. You have a remainder of 4, right? So because of this remainder 4, you just need to subtract it by 4 to get the previous number that's divisible by 8. That's 456. To get the next one, you add 8 to it. That's 464, right? All right. So because 464 is divisible by 8, B has to be 4. Now instead of doing this division over here, you can also mentally try numbers, because you already know the first two numbers 4 and 6, right? So you can try 1, 2, 3, 4, and using the pattern in your mind also you can find the answer. Now we know that B is equal to 4. Let's move on with the question. This given number can now be written as 8A51464. Now this number has to be divisible by 11 also, right? Because we have 11 over here. Let me give plus and negative signs to alternating numbers starting from the right. Alright, let me do that. Now these areas will have negative sign. Now if I add all the positives, that's 8 plus 5 plus 4 plus 4, that's 21, right? Now if I add all the negatives, that's minus A minus 1 minus 6, or it can be written as minus A minus 7. Now when I add these two, that's 21 minus 7 minus A, that simplifies to 14 minus A, and from the divisibility rule for 11, we know that 14 minus A should either be 0 or a multiple of 11. Now I can see that if I give A the value 3, right, 14 minus 3 will give me 11, which is a multiple of 11, and from the options I can see I have such a value. I have 12 over here. Therefore, I can see that B is equal to 4 in this case and A is equal to 3, and my answer is 4 into 3, which is equal to 12. Let's do this question. A positive number is divided by 100 to get a remainder thrice as the quotient. If the number is divisible by 11, then how many such numbers are possible that are less than 1,0,0,0,0,0. All right, pause the video, give it a try, and then we'll do it together. All right, I hope you have given it a try. Let's do it together. It's mentioned over here that when the number is divided by 100, right, you get a quotient and the remainder is 3 times the quotient. That's the remainder. This is the quotient, right? Therefore, I can write the number as 100 times the quotient plus the remainder, right? Number is divisor into quotient plus remainder, right? So this is my number, or the dividend. You call it the dividend. All right. Now 100x plus 3x can be simplified as 103x. All right, and it is mentioned that this is divisible by 11. Okay, so if 103x has to be divisible by 11, I know that 103 is not divisible by 11, right? I know 99 is divisible by 11, so the next value that will be divisible by 11 is 99 plus 11, which is 110. So 103 is not divisible by 11. So if 103 into x has to be divisible by 11, then x has to be divisible by 11, or I can write x as a multiple of 11. Say x is 11p. All right, so x has to be 11p. All right, now over here 3x is the remainder, and 3x has to be less than 100, right? Because the remainder always has to be less than the divisor. Whenever you do a division operation, the remainder always has to be less than the divisor. You cannot get a greater remainder, because that would mean that the quotient could be increased by 1, right? What does that mean? Let me quickly write it over here. If you divide 10 divided by 3, right, you can only get a remainder up to 1 or 2. You cannot get a remainder 4. Over here you can see your, it's 3 into 3 plus 1, your remainder is just 1, right? Or 11 divided by 3, it's 3 into 3 plus 2. Or 12 divided by 3, you cannot get a remainder greater than 2, that's 3 into 4. Or it's 3 into 3 plus 3, but now because you have a 3 over here, it increases the quotient by 1, that's why you get 3 into 4. All right, using this principle, we can see that 3x has to be less than 100. That is, the remainder has to be less than the divisor. All right, if 3x has to be less than 100, and we know that x has to be a multiple of 11, or we have written it as 11p. So I can write 11p into 3, or 33p has to be less than 100, right? Now, what are the values that p can take to satisfy this? P can take the values 1, 2 or 3, right? 3 into 33 is 99. If p takes the value 4, 33p will be more than 100. So this criteria will be violated. So p can take only 3 values, and therefore my answer over here is 3. There are only 3 such possible numbers. Hi students, in this video we are going to derive some divisibility rule for 7, 13 and 37. Alright, let's start with 7. Say I do 10 divided by 7. What is the remainder I would get? I'd get a remainder of 3, because 10 divided by 7 goes once. So the quotient is 1 and the remainder is 3. Now if I do 100 by 7, that's 10 into 10 by 7. I can split it like this, right? 10 by 7 remainder into 10 by 7 remainder. Over here I'll get a remainder of 3, because that's what we have seen over here. Similarly over here I'll get a remainder of 3, and that comes to 3 into 3, which is 9. 9 by 7 remainder gives me 2. It goes one time, so 9 is 1 into 7 plus 2. Alright, so 10 by 7 gives me a remainder of 3. 100 by 7 gives me a remainder of 2. Let me try 1000 by 7. 1000 by 7 gives me a remainder of minus 1. How is that? 1000 by 7 can be split as 10 by 7 remainder into 10 by 7 remainder into 10 by 7 remainder, right? And we have seen that this gives 3. This is 3 into 3 into 3 divided by 7 remainder. 3 into 3 is 9. 9 by 7 gives me a remainder of 2. So I can write this as 2 into 3 by 7 remainder. This is nothing but 6 by 7 remainder, and the remainder over here is 6, right? Or I can write it as a remainder of minus 1. Why? Because I can write this 6 as 0 into 7 plus 6. That's the case where I have remainder of 6. Or I can write 6 as 1 into 7 minus 1. That's the case where I have a remainder of minus 1. Now I take this minus 1 over here. Now we have identified a power of 10, which when I divide it with 7 gives me a remainder of minus 1. So basically in all these cases we are trying to identify if there is a power of 10 such that when I divide it with 7 or 13 or 37, I get a remainder of 1 or minus 1. Why? Because this makes my calculation very easy. Alright, let's move on. So I make some space over here, and we have found so far that 10 to the power 3 divided by 7 gives me a remainder of minus 1. I make a note of that. That's what I wanted to find out. Now we'll do the same thing for 13 and 37 so that we can write the rule for these three numbers together. Alright, let me note this over here. I have minus 1 over here. Now if you do the same thing for 13, you will find that 10 to the power 3 divided by 13 also will give you a remainder of minus 1. Let's quickly do that. 10 by 13, what's the remainder? 10 by 13 gives me a remainder of minus 3, right? I can write it as 13 into 1 minus 3. So that's a remainder of minus 3. Now if I have 10 square by 13 remainder, that would be minus 3 into minus 3, which is 9. 9 by 13 remainder, that gives me a remainder of 9. And if I take 10 cube by 13 and if I take the remainder of this would be 9 into 10 by 13. You take the remainder, say 9 into 13, let that be taken as minus 4, and 10 by 13, let's take it as minus 3. So I get 12 by 13, and taking the remainder, that gives me a remainder of minus 1, right? Remainder of 12 and remainder of minus 1 is the same when the divisor is 13. We have already seen that. Alright, so make a note of it over here. Let me clear some space. So we have arrived at a power of 10 both for 7 and 13. When that power of 10 is divided by 7 and 13 respectively, we are getting a remainder of minus 1. Let's try the same thing for 37 also before we go ahead with the rule. Alright. Now, if you do 10 to the power 3 by 37, you will see that your remainder is 1. Now, having attained this part in these three cases, let me keep that aside. Now, using this, we can easily find the remainder of a number. Let's say take an example 2789253. Now, because in these cases, see, we are taking the power of 3, right? In all the three cases, it's with the power of 3 that we were able to arrive at minus 1, and 1. In the case of 7, 13 and 37 respectively, right? Therefore, we have to divide this number into triplets. So I take 3 digits at a time and I start from the right to the left, okay? So I can draw a line over here and a line over here. Alright, now let's start with 7. Say I want to find out 2789253 divided by 7 and find the remainder for this operation. Alright, what I need to do is I need to give a plus in the first triplet. The second triplet will have a negative and the third triplet will have a positive. Now why is that? Over here you can see that 10 to the power 3, when you divide it with 7, you're getting a remainder of minus 1, right? Now in the expanded form of this number would be 2 into 10 to the power 6 plus, let me club this together because we are taking triplets, that's 789 into 10 to the power 3, right? Because you have 3 digits over here, and I can write it as plus 253 into 1. Okay, now over here I can see that if I divide this with 7, right, and take the remainder, that's equivalent to taking the remainder in each of the cases, right? So let me write that over here like this. Now when you take the remainder like this, and if the number obtained when you add the respective reminders is greater than 7, you have to again divide it by 7 and find the remainder. Alright, over here you can see that 10 to the power 3 divided by 7 gives me a remainder of -1. That's what we obtained over here. That's why we are giving a minus sign over here, and this is -789. Over here 1 by 7 gives me a remainder of 1 itself. That's why we write a plus over here, and that's 253 itself. And over here you have 10 to the power 6 by 7. If 10 to the power 3 by 7 is -1, 10 to the power 6 by 7 will be -1 into -1, which is 1. That's why you have a plus over here, and that's just 2. So that's how we arrived at these signs. Let me make some space and we'll move ahead with our method. Alright, now having established why these signs come over here, let's move ahead. So what you do is, you have 2 over here and you have 253. If you add them, you get 255, and you have -789. So let's subtract these two. So 789 minus 255 will give you 534, and this one has the negative sign, so this will be a negative 534. So when you apply the signs and add the numbers together, you get -534 by 7 remainder. So this number 2789253 divided by 7 and -534 divided by 7 will have the same remainder. Alright, now let's find this answer of this -534 divided by 7. Alright, I've made some space over here. I can do the division. 534 divided by 7. It goes 76 times and I get a remainder 2 over here. Because I have a minus over here, this is a remainder of -2. And remember, when the divisor is 7, -2 remainder is the same as a remainder of 5. And using this, we have been able to solve this question. Alright, now let's do the same for 2789253 divided by 13. Alright, over here also, because it's for triplets and it's -1, it's the same rule. So you divide it into triplets, you give a plus over here, a minus over here, and a plus over here. That amounts to -534, just like what we did over here. And all we have to do is -534 by 13. If you do the division, you will get a remainder of -1, which is equal to a remainder of 12 when the divisor is 13. Alright, so we have successfully established a rule for checking the divisibility of 7 and 13, and we have done one example for each of these. Now let's do a question for 37. Say you want to do 2789253 divided by 37. Now in the case of 37, we have seen that 10 to the power 3 divided by 37 gives you a remainder of +1. Therefore, after dividing the number into triplets, you have to give plus in all the triplets. Now you just need to add this up. So this adds up to 1044. So 2789253 divided by 37 and 1044 divided by 37 will have the same remainder. Now this part over here will have the same remainder as 45 divided by 37. Why is that? Because this is a 4-digit number. I can split this also into triplets and give a plus. So this becomes 44 plus 1, which is 45 divided by 37. Now 45 divided by 37 will give you a remainder of 8. Let's do this question. 10 to the power x divided by 7 gives a remainder of 1. The question asks, how many natural numbers less than 100 satisfy this equation? So you need to find values for x where 10 to the power x divided by 7 will give you a remainder of 1. Pause the video, give it a try, and then we'll solve it together. Alright, I hope you have given it a try. Let's do it together. We know that 10 to the power 3 divided by 7 gives a remainder of -1, right? We have already seen that in the previous video. Therefore, 10 to the power 6 divided by 7 is equal to 10 to the power 3 by 7 into 10 to the power 3 by 7 remainder, right? Now over here this is -1 and this is -1. Therefore 10 to the power 6 when divided by 7 will leave a remainder of -1 into -1, which is equal to 1. Now, so any power of 6, right, any multiple of 6 will give you an answer to this question. So you just need to find multiples of 6 which are less than 100. Now, in the first 100 natural numbers, how many multiples of 6 are there? That's nothing but 100 divided by 6, which gives you the answer as 16. Now, why does this work? Let's just take an example. Say for example, 6 into 2 is equal to 12. Now, if you do 10 to the power 12 divided by 7, and if you want to find the remainder, that's nothing but 10 to the power 6 divided by 7 remainder into 10 to the power 6 by 7 remainder, right? Because we know 10 to the power 12 can be written as 10 to the power 6 into 10 to the power 6, because the base in these two are the same. Therefore, if you do 10 to the power 6 into 10 to the power 6, that's equal to 10 to the power 6 plus 6. Therefore, you can split it like this. Over here you get a remainder 1, and over here you get a remainder 1. Therefore, the remainder of 10 to the power 12 by 7 is 1. It's that property which has given us the answer as 100 by 6 or 16. Now, there's one more thing that you can note over here. Say for example, in the question, instead of 1, it was mentioned -1. That is, 10 to the power x by 7 gives a remainder of -1. Then you should have found the multiples of 3 which are not multiples of 6, right? Because multiples of 6 will give you a remainder of 1. When you do 10 to the power 6 by 7, the remainder is 1. But for example, 10 to the power 9 by 7 will give you a remainder of -1, right? Therefore, you have to find multiples of 3 which are not multiples of 6 if the question had -1 over here instead of 1. Let's do this problem. Find the remainder when 215, 215, 215, etc. up to 150 digits is divided by 13. So this can be rewritten as 215, 215, etc. 150 digits. You divide this number by 13 and the question asks us to find the remainder. Pause the video, give it a try, and then let's do it together. Alright, so the numerator over here is 215, 215, etc. and it will end in 215, 215, 215, right? Now, we know that 10 to the power 3 divided by 13 gives a remainder of -1. Therefore, let's divide the given number into triplets from the right. So I can do that like this. Now, once I've done that, I have to give alternating plus and minus signs to these triplets, starting with a plus from the right. So let's do that. Now, once we have done that, you can see that because there are 150 digits over here, there will be a total of 50 sets, right? Each set has 215, right, in each triplet, and there will be 50 triplets because there are 150 digits in this given number. Therefore, you can see that 25 triplets will have plus 215 and 25 triplets will have minus 215. Therefore, when you add them, you'll get 215 into 25 and minus 215 into 25. Now, when you add these two together, it adds up to 0, right? Therefore, you can say that when you do this operation, 215, 215, etc. up to 150 digits divided by 13, the answer of this is the same as 0 by 13 and taking the remainder, and that gives you the answer as 0. In this section, let's try to understand the divisibility rule for 25 or 125. These are powers of 5. Alright. We have already learned that the divisibility rule of 5 is that the last digit has to be 0 or 5. Now, when it comes to 5 square, which is 25, you need to find a number such that the last two digits are divisible by 25. Then the whole number will be divisible by 25. Similarly, if a number has to be divisible by 5 to the power 3, then the last three digits have to be divisible by 5 to the power 3. Now, you can see that when you had 5 to the power 2, you had to check the last two digits. And when you have 5 to the power 3, you have to check the last three digits. Now, why is that so? That's because, say in this case, 2 is the least power of 10. which when divided by 25 gives a remainder of 0. So what do we mean with that? If you have 10 to the power 1 divided by 25, you don't get a remainder 0. Alright, so 10 to the power 2, that's 100. When you do 100 by 25, you get the remainder as 0. Therefore 2 is the least power of 10, which when divided by 25 gives you a remainder of 0. Therefore, say you have a number ABC, right? So you can write this as A into 100 plus B into 10 plus C into 1. Now A into 100 will always be divisible by 25. So you just need to check the last two digits, which is B and C. The last two digits need to be divisible by 25 for ABC to be divisible by 25. Alright. In a similar manner, you can see that if a number has to be divisible by 125 or 5 to the power 3, the last three digits have to be divisible by 125. That is because 3 is the least power of 10, which when divided by 125 gives a remainder of 0. Let's do this question. Let n be the number of 4-digit numbers divisible by 25 with the digits 2, 5, 0 and 3, no digit being repeated in the numbers. What is the value of n? So you need to find how many such numbers can be formed. Alright. Now it's given that these numbers are 4-digit numbers and you need to use the given digits 2, 5, 0 and 3, and the number that you form should be divisible by 25. So how many such numbers can you form? Pause the video, give it a try, and then we'll do it together. Alright, we are back. It's mentioned that the number that we form should be divisible by 25, and we know that for a number to be divisible by 25, the last two digits should be divisible by 25. Now, what are the possibilities over here such that these last two digits will be divisible by 25? You can either have 0, 0, 2, 5, 5, 0 or 7, 5, right? 7, 5 plus 25 again will give you 0, 0. So there are only 4 possibilities that can occur in the last two digits such that the number, the 4-digit number that you form will be divisible by 25. Now, you have only 2, 5, 0 and 3, and it's also mentioned that no digit can be repeated. So you cannot have 0, 0 because you have only 1 0 provided. Alright. Can you have 2, 5? Yes, you have 2 and you have 5. So 2, 5 is possible. Similarly, 5, 0 is also possible because 5 and 0 are provided. But 7, 5 is not possible because we are not provided the digit 7. Alright. So there are two cases over here. The last two digits can be 2, 5 or the last two digits can be 5, 0. Alright. Now, it's a 4-digit number. Let me fill the last two digits with 2, 5. Now, the other two digits can be filled as 3, 0 or I can fill it as 0, 3, right? Now, this one is valid. It's a 4-digit number and it's divisible by 25. But this one is not valid because you have 0 over here. So this is not a 4-digit number. This is actually just a 3-digit number. Alright. Now, let me fill the next case. Let me fill 5, 0 in the last two digits. So I have 5 and 0 over here. Now, let me fill the other two digits over here as 2, 3, or I can fill it as 3, 2, like this. Alright. Now you can see both these numbers are valid because they are 4-digit numbers. Therefore, the answer of n is 3. There are 3 such numbers which you can form. The numbers are 3025, 2350 and 3250. Hi students, in this section, let's try to learn how we can apply the divisibility rules to find the remainder. Now, many times checking the divisibility is a yes or no question. Say you are given a number and you want to know if that number is divisible by 11. So yes would imply that the remainder is 0. Yes, the given number is divisible by 11, for example, and no would imply that you get a remainder which is greater than or equal to 1 and less than the divisor, right? If the divisor is 7, you can have a remainder at max of 6, right? Alright, so now what do I mean when we say that we are getting a remainder? It means that the dividend is equal to the quotient into divisor plus remainder, right? For example, if you are dividing 12 with 5, you get a remainder of 2. So that means when you do 12 divided by 5, right? your quotient is 2, your divisor is 5, and your remainder is 2. And you can note that 2 is less than your divisor, which is 5. Alright. Now, having this established, let's see how we can use the divisibility rules that we learned for these numbers to find the remainder. That's what we aim to achieve in this section. Now, also do remember, we have seen it quite a few times, the concept of negative remainder. If I do 12 divided by 5, my remainder is 2, which is the same as minus 3. Why is that? You can write 12 either as 2 into 5 plus 2. So that's the expression which shows a remainder of 2. Or you can write 12 as 3 into 5 minus 3, right? So in this expression, you can see that over here you have a remainder of minus 3. So having a remainder of 2 or mentioning it as minus 3 is the same in the case where your divisor is 5. You can note that 2 plus 3 without the minus, 2 plus 3 is equal to your divisor, which is 5. Alright. Now having established that, let's keep this aside and let's take some numbers and see how we can apply the divisibility test to find the remainder. Say you want to find 37 divided by 2. That would be equal to 7 divided by 2, because as per the rule for 2, only the last digit counts for divisibility, right? So 37 by 2, if you want to find the remainder, you just need to check the last digit. That's equal to 7 by 2 and taking the remainder, which is equal to 1. Alright, now let's go on for 3. Say you want to do 37 divided by 3 and finding the remainder. If you want to do that, you just need to take the digit sum, because the divisibility test for 3 was digit sum. So to find the remainder also, you can do 3 plus 7, that's 10. So 37 by 3 taking the remainder is the same as 10 by 3 taking the remainder. And 10 by 3, you know, it goes 3 times and you get a remainder of 1 over here. Now let's try another question. Say you want to do 237 divided by 4. That would be the same as 37 by 4 and you get the remainder as 1. Why is that? In the case of 4, we have seen that the divisibility rule was that the last 2 digits should be divisible by 4. So 237 by 4, if you want to find the remainder, and taking only the last 2 digits, that's 37 by 4, finding the remainder, both of these are the same. And when you do 37 by 4, you know it goes 9 times, that's 36, and you get a remainder of 1. Alright, let's move on to 5. For 5, we know that the rule was the last digit should be 5 or 0. So say you want to do 237 divided by 5, you just need to check the last digit. So that's equal to 7 by 5 and taking the remainder, and you get the remainder as 2. Alright, now let's move on to 8. Remember 6 is a composite number, that's why we are skipping it. So for 6, we had learned that you have to find divisibility, you have to check divisibility of 2 and 3. Alright, now let's move on to 8. Say you want to do 4583 divided by 8 and you want to find the remainder. So for 8, the rule was the last 3 digits should be divisible by 8. So you just need to take the last 3 digits over here. That's 583. And if you do 583 by 8, if you get a remainder, that would be the same as 4583 divided by 8. Alright, now let's move on to 9. Say you want to do 37 by 9. For 9, the digit sum had to be divisible by 9. So the digit sum over here is 3 plus 7, that's 10. Again, you can take the digit sum of 10, that's 1 plus 0, that's 1. And that is your answer. So when you want to divide by 9, you just need to find the digit sum and your remainder is 1. Alright, so we have covered 9. Say you want to do 10, 37 by 10. You just need to check the last digit. That's your answer. So 7 is the remainder in this case. Now let's move on. So we have covered the numbers till 10 and we just left with 11. So say you want to do 4937 divided by 11 and you want to find the remainder. So start giving signs from the right to the left, starting with a plus over here. So that would be plus, minus, plus, minus. Now if I add this minus 4 plus 9 minus 3 plus 7, that amounts to 9. So 4937 by 11 taking the remainder is the same as 9 by 11 taking the remainder. And 9 by 11, if you want to find the remainder is 9 itself, or you can write it as minus 2.